Okay, this is problem 3.2, part A on page 68 of your comparing bits and pieces. Okay, first question says, decide in which interval on the number line each fraction below is located. So you have a bunch of fractions here. Quite a lot of fractions, and we're going to decide in which interval, whether they are between -1.5 to -1, -1 to -1/2, -1/2 to 0, or 0 to a half, and 1 and half to 1, and then 1 to 1.5. Okay, so let's start with the first one, 1/5. So let me get this ready. Alright, so I have pens ready. 1/5. So 1/5, you've got to decide where 1/5 lies first of all. So easy way of doing this is to draw a very ugly rectangle like I am. Okay, and cut it into 5 pieces. 2, 3, 4, 5. Now, 1/5 is this much. You can tell by the picture that that's less than a half of a full, I guess we can stick to chocolate bars. Okay, so that's less than half. So if I ate that piece right here, that would mean that I ate less than half. So from 0 to 1, if we imagine this as a chocolate bar, this is a halfway line. You can tell by the picture here on top that 1/5 is about about here, which is less than half. Okay, so 1/5, our first fraction, is right here. Okay, our second fraction, let's see, is 4/5. Ooh, I shouldn't have erased that. Now, with 4/5, it's the same thing. Gee, okay, sorry. Alright, so with 4/5, you can tell that 4/5, and I'll draw it somewhere over here. Okay, again, let's draw a rectangle. Cut that into 5 pieces. 1, 2, 3, 4, 5. And if you ate 4 out of the 5 pieces available, you can tell that it's more than half. So 4/5 lies between half and 1. It's not entirely of one full chocolate bar, but almost. So 4/5 will lie somewhere around here, and that makes it belong to this particular interval. Okay, -1/3. Well, -1/3. Okay, it's something that's cut into 3 pieces. Okay, and you've got to decide whether -1/3 is between 0 and -1/2, or -1/2 and 1. So again, take that bar, and this time you cut it into 3. Okay, and you take one piece. It's obvious by the picture that it's less than a half. Alright, but since we're talking in the negative area, it has to be between 0 and -1/2. So 1/3 would be about here, which makes it go in this particular area. Okay. Notice that I'm using drawings, okay, pictures, to figure out where to lie, where that particular fraction lies. Okay. So next one we have chocolate bar. 1, 2, and again it's -2/3. So by cutting a chocolate bar into 3 pieces, and if you take 2, you're obviously eating a little bit more than a half. So -2/3, this is 0, this is -1/2, so your chocolate bar is going to be a little bit more than a half here. Okay, so -2/3 somewhere over there, which brings us over here. Okay. 1/10. Next fraction is 1/10. 1/10 is a very tiny piece. Okay, so if you have a chocolate bar and you cut that into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, and you take one piece out of that chocolate bar, that is a very tiny piece, and obviously it's less than a half, and so that fraction is going to be between 0 and half. So 1/10 goes over here. 6/10. So let's keep that same picture, and let's say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6/10. Okay, so let's take half. Let's take 6/10. Well, you can tell that 5/10 would be same thing as half. Another way of saying a half is 5/10. So because we ate 6, it's a little bit more than a half. So 6/10 would be about here, which makes it over here. Okay. 1 and 5/12. 1 and 5/12. It's on the positive side. Okay, so let me erase this. 1 and 5/12. Okay, so it's obviously more than 1, so the number we're talking about is 1 and 5/12. So you got to figure, we know it's more than 1. Now, is it between 1 and 1.5 or 1.5 and beyond? Okay, so it's going to be somewhere in this area right here. Or 1.5 and more. So 1 and 5/12. So the 1 stays. Let's focus on the 5/12. Okay. Now, another way of saying, so if you have half and you wanted to make an equivalent fraction using 12s, all 2 times a particular number is 12, it's 6. So 1 times on top times 6 would be 6. So another way of saying a half is 6/12. Now we can compare a little bit easier. So 5/12 is less than 6/12 or less than a half. So 1 and 5/12 lies between 1 and 1.5. So it's somewhere right around here. Okay. 7/8. Next fraction is 7/8. 7/8, if you have a chocolate bar and you cut into 7 pieces, okay, that's half. I cut that half, I get 4. If I cut each fourth, now I get 8. So, chocolate bar, and you take 7 pieces. You still don't eat 1 full bar, but it's very close to 1, so it's about here. Okay, so by being here, you're somewhere between half and 1. So let's write 7/8 over here. Okay. Next, we have 9/8. Ooh. Well, listen, it's an improper fraction. Okay. So 9/8, if I were you, I would change that to a mixed number. Sorry. 8 goes into 9 once. You have a 1 left over, and it's 1 and 1/8. So if you eat 9/8 of a chocolate bar, that means you ate 1 full chocolate bar and 1/8 of another one. So you know it's going to be more than 1. And 1/8. Let me draw the 1/8 here for you. 1, 2, 3, 1, 2, and it's 1 full chocolate bar and a little piece of a second chocolate bar. So that would be around here. Okay, 1 and 1/8. Okay. 1/8. 7/9. Ooh, wait, where am I? 7/9. Yes, 7/9. Oops, why am I moving that? Okay, so 7/9. Let's take the fraction 7/9. Okay, and draw it. You have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you have a chocolate bar and you cut into 9 pieces, 1, 2, 3, 4, 5, 6, 7. You can tell you are very close to eating a full chocolate bar. So that means it's more than a half, but still less than 1. So it'd be somewhere around here, which makes 7/9, the fraction that comes over here. 3/4. Okay. 3/4 once again. Okay. If I want to draw this, you get 3/4. And here's your chocolate bar. 1, 2, 3, 4. And you take 3 pieces. You can obviously tell here that it's more than half, but still less than 1. So it's between somewhere in this section. So I'm going to write 3/4. Okay. 3/12. Okay. Now 3/12. I'm hoping that you can realize that you can simplify. So here we have 3/12. If you simplify, divide top and bottom by 3. 3 divided by 3 is 1, and 12 divided by 3 is 1/4. Okay, so much more manageable. 1, 2, 3, 4. Chocolate bar cut into 4 pieces and you took 1. You can tell that's less than a half. It's still more than 0, so it's between 0 and half. And we're going to write that 3/12 over here. Okay, so the trick here, or faster way to do this is to simplify 3/12. Negative 1 1/3. Okay, so 1 1/3 negative. So that means it's a full chocolate bar that you ate, and another chocolate bar, and you're taking a piece of the knife. So again, it's negative, but we can still use, I guess, the chocolate bar example. So here's 0. Let's walk to 1, because that's, you know, 1 full chocolate bar, and you ate a piece of a second chocolate bar, which is less than half. So that lies somewhere over here. So we're gonna say that that looks right here. 1, negative 1 and 1/3. Okay. And let's erase this one. Actually, let me erase this one. Negative 1 and 1/3. Negative 1 and 1/3. 8/10. Okay, our next fraction is 8/10. So if I were you, I would have simplified that, make that 4/5. Okay, if you have a chocolate bar and you cut it into 5 pieces, 1, 2, 3, 4, 5, and you take 4, you can tell by the picture that it's more than half, but less than 1, so it's somewhere in this area. So 4/5 would be between half and 1. I'm sorry, not 4/5, but 8/10. Okay, so 3/8. Okay, so 3/8 is our next fraction, and can't simplify that. So 3/8. So you have something here that's cut into 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8, and you take 3. You can tell that's less than a half, because to be half would be 4/8, but it's 3/8, so it's somewhere between 0 and a half. So that would be somewhere over here. Let me squeeze that in. Negative 5/4. Okay, it's a negative. So 5/4, it's still an improper fraction. If you change that negative, that you would get 1 1/4. Okay, so it helps if you change it to a mixed number. So even though it's negative, we can sort of use a chocolate bar. So you ate 1 full chocolate bar and 1/4 of a second one. So here's your second chocolate bar, cut into 4. So you ate 1 full chocolate bar and a quarter of a second one, which is still less. So it's between 1 and negative 1/2, somewhere around here. So let me write this down. Negative 1/4. So again, the trick here was to change it to an improper fraction. I'm sorry, mixed number. Okay. Next fraction is negative 3/4. Let me erase this here. Negative 3/4. So negative 3/4 is not, again, here's your chocolate bar. You get 1, 2, 3, 4, and you take 3 pieces. You're taking more than half, but still less than 1. So here's 0. This is half. So you take a little bit more than half, but still less than 1. So it has to be somewhere over here. Okay, so it's between half and negative 1. So right here. Negative 3/8 is our next one. Okay, guys, negative is just a mirror image. Okay, same thing, but it has a negative sign. So negative 3/8. Here's your chocolate bar, negative chocolate bar, I guess. I shouldn't say that. Here's something that's cut into 8 parts, and you take 3. That's less than a half. Okay, so it's still more than 0, but less than a half. So it just treat it as negative. So it's, instead of this side, it's going to be on the left side of the 0. So 0. Okay, and you're not going to go all the way to the half, but you're going to be a little less, so somewhere around here. And that's where we're going to write that fraction. 5/6, negative. Again, here's 5, something cut into 6 pieces. 1, 2, 3, 4, 5, 6, and you took 1, 2, 3, 4, 5. You can tell that's more than a half, but still less than 1. So again, the only thing is that it's on the negative side. So here's the half. little bit more than half, but less than 1, so around there. Okay, so that would be negative 5/6. 3/7. Positive, something that's cut up in 7 pieces, and you take 3. So 1, 2, 3, 4, 5, 6, 1, 2, 3, and you take 3 pieces. Okay, 3/7. You gotta decide if it's more than half or less than half. All right. So if you have 7, okay, half of 7 would be 3.5. No, yes, 3.5. That's half of 7. That equals to half. Okay, but our fraction is 3/7, and 3/7 is less than 3.5/7, which makes it less than half. So it's between 0 and a half, so we're going to write that right here. Then we have 4/7, so let's keep that picture. Okay, and here's our chocolate bar. There's 7 pieces, and I took 4. That is more than a half, just over, a little bit over a half. So here's a 0, there's a half, and there's 4/7, so it's between half and 1. Okay, 4/7 is a little bit more than half. Okay. 1/3. Okay. 1/3. Yeah, something that's in thirds. You take 1/3. You can tell that by the picture that it's definitely less than half. Okay, so it's between 0 and a half. So that's where I'm going to write 1/3. And then you have 2/3. 2/3. If you have a chocolate bar and you cut it into 3 and you take 2/3, that's more than a half, but it's still less than 1. So it's here. Okay, it's somewhere in this area. And finally, negative 7/6. So negative 7/6. So we got something that's cut into 7 pieces. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. All right, and you're taking 3 pieces. Okay, 3, 6. Oh, I'm sorry. You're taking 6. 1, 2, 3, 4, 5, 6 pieces. It's almost a full chocolate bar, but on the negative side. So here's 0. Okay, and you almost reach 1. So actually, that marker, it's about here. So that's between -1 and negative half. Okay. Part B on page 69. It says insert a less than or greater than, okay, symbol in each one. So number 1, you get, let me use another page. -5. Oops. -5 blank 3. -5 is a negative number. Greater than a positive number? Never. So this one has to be less. -5/2 is less than 3. 2, 0, and -3. Okay, again, let's draw a number line here. So it makes it, if you ever are in doubt, draw a number line at the bottom. So here's 0. This is -1. This is -2. This is -3. Make an X and an X. Remember I told you in class, the number on the right will always be greater. So who's on the right side? 0 is. So this guy is greater than -3. The number on the right will always be greater. -5/3 and -11/2. Ooh, tricky. Okay, key here, if I were you, I'd change that to a mixed number. Okay, 3 goes into 5 once, 2 left over, negative. 2 goes into 11 5 times, and you have 1 left over and a half. Still doesn't help us. Okay, so on the side, draw a number line. So that's 0, that's 1, that's 2. Okay, it's not to scale, right? 3, 4, 5. So let's locate our first number. -1, so here's 0. I'm walking, and reach -1, and I'm going to go 2/3, so a little bit over. So that's my first number. -1 and 2/3. Second number, -5.5. So here's 0. I'm walking to the left. -1, -2, -3, -4, -5, and -5.5 should be somewhere around there. So now that you have both of them on the number line, it's much easier to compare. The number on the right, who's on the right? This guy right here, is greater. Okay, so we're going to say negative 1 2/3 is greater than negative 5.5. Okay. 4. Callum says that every number is greater than its opposite. Do you agree? Every number is greater than its opposite. So let's take an example. So you know what? When you have sentences like this, pick a number. So let's take 5. Every number, this number is greater than its opposite. Well, that's true. I took a number and I wrote its opposite, negative 5, and guess what? The number is greater than its opposite. Let's pick a negative number. Negative 2 is greater than its opposite. The opposite of negative 2 is 2. Ooh, it does not work. It works if your first number is a positive, but when I tried that statement with a negative number first, negative number, which I picked, negative 2 is greater than 2. That is not a true statement, so Callum is wrong. That does not work for all numbers. So the trick here is to pick a random number and try it. In this case, actually, you should have tried with 2 random numbers. One positive, starting with a positive number and finding its opposite, which was a negative. And then doing it again, starting with a negative number and then picking its opposite and seeing if it works. And it doesn't work for the second one, but it works for this. So Callum is half right. 5. Blake says that he can use absolute value to help order numbers. Negative 6 over negative 6 over 5 and negative 2/3. He says the absolute value of negative 6/5 is greater, so it's farther away from 0. So let's change this to a mixed number, which is 1 1/5 negative. Okay. So therefore, negative 6 is less than negative 2/3. He says the absolute value is greater. The absolute value of this guy, remember, absolute value has 2 bars like this, is 1 1/5. Okay, because that's how far it is away from 0. And the absolute value of negative 2/3 is 2/3, because you need to take 2/3, move 2/3 to get to 0. So that's the absolute value of that one. And he says that whoever has the greater absolute value is the bigger number. Do I agree? So therefore, if he were to write this, he would say that negative 6 over 5 is it's less than negative 2/3. All right. I'm not sure I like his method here of thinking, because he says the absolute value of negative 6 over 5 is greater. True. Okay, because the absolute value is 1 1/5, and the absolute value of the other guy is 2/3. But because the absolute value is greater, he's thinking that because the absolute value of that number is greater, it makes this a true statement. Because, well, it works for negative numbers, but it wouldn't work for positive numbers. Okay, he has a point. The further you are away from 0 on the negative side, the less of a value you're going to have. So here's 0. Here's negative 2/3. Okay, and here is negative 6 over 5. He's absolutely correct. This number right here is further away from 0 than negative 2/3. Therefore, it has a smaller value. But if we were to do this with absolute values with positive numbers, that would not work. Okay, so let's take this on the other side here. Here's 0. Let's pick a number 2 and pick a number 4. The absolute value of 4 is 4. The absolute value of 2 is 2. On the positive side, the further away you are from 0, the bigger your value. Okay? And on the negative side, the further away you to the left of 0, the less your value. Okay, so careful here. 6. Bill's strategy, Blake's strategy work for all comparisons you did in questions 1 through 3. Okay, see? It will only work if both numbers are negative. Okay, and for number 1, no, it won't work. Okay. All right, so let's see. C, compare each pair of fractions using benchmarks and other strategies, then copy the fraction. Okay, so 5 over 8 and 6 over 8. Oops. Let's make, oh, I hate when I do this. 5 over 8. Okay, so, no, okay. Hang on a second. I don't know what I'm doing here. Number. All right, so let's see. 5 over 8 and 6 over 8. This one, well, it doesn't need discussion. Okay. Yeah, a chocolate bar cut in 8 pieces. Somebody takes 5. The other person takes another chocolate bar and cuts in 8, takes 6. Who took more? Obviously, this guy. So 5 or 8 is less than that. Okay. Now, 5 over 6. Ooh, and 5 or 8. Alright. In this case, okay, I would try to find equivalent fractions. Okay. I'm going to change these two to new fractions. Now, can you guys think of a number? Okay. We're trying to find a common denominator. Can you think of a number that 6 and 8 can go into? Both. So it has to be a multiple of 6 and a multiple of 8. So we're looking for the LCM of 6 and 8. So if you're going to do LCM, remember 6, let me do an 8 here. Multiple 6, 12, 18, 24, etc. 8, 16, 24. Oh, look at that. So another way of writing 5 or 6 and 5 or 8 is using a fraction with a denominator of 24. 6 becomes a 24 by multiplying by 4. So if I multiply the bottom by 4 and multiply the top by 4, I get 20. 8 to become a 24 is times 3. And therefore I have to multiply 5 times 3, giving me 15. Much easier to compare now that both fractions have the same denominator. Okay, here's a chocolate bar that you cut into 24 pieces, you took 20. Here's another chocolate bar you cut into 24 pieces, but somebody else took 15. So who took more? Obviously the person who took 20. So that means that this fraction is greater than that. So it means that 5 over 6 is greater than 5 over 8. Okay, so here's another strategy that you can use. 2/3 and 3 over 9. All right. This one, I'm going to rewrite them again, but I'm only going to rewrite one. 2/3 I'm going to keep, and 3/9 I'm going to simplify. So 3/9 becomes 1/3. Excuse me. When the denominators are the same, you can easily tell which one is greater or not. So in this case, 2/3 is greater than 1/3. Okay. Get a new page. Next one, 13 over 12. Oh, gee. So you got 13 over 12, and we're going to compare it to 6 over 5. All right. By now, I'm hoping you can notice that these are improper, and you got to change it to a mixed number. So 12 goes into 13 once, 1 left over 12. 5 goes into 6 one time, and you get 1 over 5. All right. So now, it's still very tricky to compare. So is it who takes more? Somebody who got 1 over 1 and 1/12 and 1 1/5. Okay, trick. Keep the 1 the same, and let's change the fractions. Okay, and again, we're using LCM. Think of a number that 12 and 5 can both go into it, or it's a multiple of 12 and 5. So if you want to do, well, list them like this and find the LCM, you're going to notice that 12, 24, 36, 48, 60. And obviously, 5, 10, 15, blah, 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 it's going to go, 60 is going to be the first number that they both match. So I can change these two fractions to a new denominator of 60. 12 times 5 is 60, so I multiply the top by 5, so I get 5 over 60. 5 times 12 is 60, so I multiply the 12, top by 12, so I get. So now it's much easier to compare, and you can easily tell that this fraction right here is the bigger one. So 1 and 5 60th is less than 1 and 12 60th. Okay? Next one, negative 3 over 4 and 2 over 5. This one you don't have to do anything. You got to realize that a positive number is always going to be greater than a negative number, so automatically negative 3 over 4 is less than 2/5. Okay. Next one. Ooh, two negatives. Negative 1 and 1/5 and negative 1 and 1/3. Alright. First thing I would do, okay, it's much easier if you change these so that the denominators are the same. So let's leave the negative 1. Okay, so think of a number that is a multiple of 5 and 3. Okay, 5 goes into that number and 3 goes into that number. So if you want to do the LCM by listing, you can. You get 3, 6, 9, 12, 15, and 5, 10, 15. Look at that. So 15 is our new denominator. Okay, to both. So here is 5 times 3 gives you 15, so therefore 5 times 1. 3 times 5 gives you 15, therefore 1 times 5. Alright, now, that still may not help you. So in case of negative numbers, it would actually help if you drew a number line. So we're looking at the negative sign, negative side. Here's 0, here's negative 1, here's negative 2. So we know we are going to the left, so we know we went 1. Okay, so, and on the second part here from negative, it's 15. So pretend you cut that in 15 parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's 15. Okay, so negative 1, and you're taking 1, 2, 3. So this is negative 1 and 3/15. Now I'll do the one at the bottom. So the other guy took 1 and 1, 2, 3, 4, 5. And this guy right here is negative 1 and 5/15. Okay? So, remember that statement. Number on the right is always the bigger one. Okay? So between these two numbers, who's on the right side? This guy. This guy is greater than the other one. So negative 1, whenever 1 and 3/15 is greater than negative 1 and 5/15. Okay? Remember, as you move to the right, your value increases. As you move to the left, your value decreases. Okay? And I guess we have one more. Alright, so let's see. There is 5 statements. Steakhouse, negative $50, which means he spent $50. Deposit, $100, which means he put in $100 on his bank account. So that's a plus. Bookstore, negative 32, which means he spent negative $32. And then deposit again, which means he put in money, $32. And then hardware store, negative 30, which means he spent $30. So question 1, which account activities have the same absolute value? The two numbers, okay, Barbara's bookstore, negative 32, the absolute value of negative 32 is 32, okay, and the deposit at Maplewood Avenue is $32, the absolute value of 32 is also 32. What does that tell me? It tells me that whatever he spent at the bookstore, he covered it the next day by depositing it money, okay, the same amount. Okay, so he's even on those two transactions. 2, Brian said that he spent less money on October 27. October 27, he spent $30. And October 21st, he spent $32. Okay. He said, oh, he spent, okay, so he said that he spent less on October 27th because the absolute value of that account is closer to 0. That's correct. So let me draw this. Here's 0. Let's make that 10. Let's make that 20. I'm sorry, negative 10, negative 20, and negative 30. So October 27, he spent this much right here. And I'll write October 27. And then October 21st, he spent a little bit more, negative $32 right here. Okay. And he's saying that on October 20th that he spent less because the absolute value of negative 30 is 30 because he's negative 30 steps away from 0. The absolute value of negative 32 is 32. Okay, because that's 32 steps away from 0. So he's saying that because, what are you saying? Yes, because the absolute value of this number, negative 30, is closer to 0. That means he spent less. He's absolutely correct. Okay. And that's it for problem 3.2. Guys, questions, any comments, please email me. Okay, on the class website, there's that contact form. Just email and I'll write it. And if I have to do a video again, I will. There's not a problem at all. Okay. And that's it for this. Watch, because I'm posting more videos for the answers for the other assignments that I gave you guys. Okay? Thanks.